All right, today we're going to tackle a statement that seems to break the most basic rule of math. But in doing that, it actually uncovers a pretty stunning truth about the universe itself. So let's just dive right in. 1 plus 1 equals 1. Yeah, I know. It looks completely wrong, doesn't it? I mean, in our everyday world, if I have one apple and you give me another one, I've got two apples. It's simple. But what if I told you that in the super strange and wonderful world of quantum physics, this equation isn't just possible, it's actually fundamental to how everything works? So yeah, that's the million-dollar question, right? How on earth is this possible? It feels like it should be a paradox, a total contradiction. But the answer isn't hiding in some weird new type of math or a clever little trick. To solve this riddle, we actually have to leave our comfortable classical world behind. We've got to step into the quantum realm, where the rules that govern all the tiny little things are completely different from anything we experience day to day. Okay, so our first clue comes from one of the most famous and maybe infamous ideas in all of quantum mechanics: superposition. This idea totally flips what we even mean by the number 1. So, what does this actually mean? Well, picture a tiny quantum particle. Instead of it being in, say, position A or position B, superposition says it can exist in a weird combination of both at the exact same time. It's not really in two places at once, it's more like it's in a single, more complex state that holds the potential for both outcomes. And this brings us right back to our crazy equation. The key here, and this is super important, is that we're not adding things, we're combining possibilities. Think about an electron spin. It can be spin up or spin down. In superposition, you combine the state of spin up with the state of spin down. And you don't get two states. Nope. You get one brand new unified state that contains both possibilities. So, one state plus one state equals one combined state. Now, let's move on to our next piece of evidence. This shows us that this isn't just some abstract mathematical idea. It has real physical consequences. See, it turns out that quantum particles don't always act like little balls. And this is that whole concept of wave-particle duality. These tiny things, like electrons, can act like solid particles, for sure, but they can also spread out and behave just like ripples in a pond. So what happens when two of those waves run into each other? This is where it gets really visual. If you've got two identical waves and they're perfectly lined up, what physicists call in phase, they don't just pass through each other, they actually merge. They combine their energy and become a single, unified wave that's twice as strong. So one wave plus a second wave gives you one bigger wave. You know, this whole idea of separate things combining into a single thing, it doesn't stop there. We also see it pop up in the logic of quantum computers and in that famously spooky phenomenon called entanglement. Now, this might look like basic computer logic, and that's because, well, it is. This principle is used everywhere, from your laptop to quantum computers. An OR gate is simple. If input A is true, or if input B is true, then the output is true. So what happens if both inputs are true? The output isn't two trues or something weird like that. It's just a single definite true. 1 plus 1 equals 1. Okay, but what if we start with two genuinely separate particles? You know, like two electrons that are created at the same time. In our world, that's 1 plus 1, and they are always going to be two separate things. But in the quantum world, something really amazing can happen. And this right here illustrates one of the absolute deepest and weirdest mysteries in all of physics: quantum entanglement. Through this process, two particles can become so fundamentally linked that they basically lose their individual identities. They start to behave as a single entity, described by one shared mathematical formula. They are one system, and what happens to one of them instantly affects the other, even if they're on opposite sides of the universe. So again, one particle plus another particle becomes one unified system. There's a name for this whole idea. It's sometimes called quantum holism. And it's captured perfectly by this phrase. Down at the quantum level, the line we draw between individual parts and the entire system, it just starts to dissolve. It completely blurs. So, what does all of this stuff, superposition, interference, entanglement, what is it all really telling us? Well, it all seems to be pointing toward a really profound conclusion about the fundamental nature of reality itself. You see, there's this core rule in quantum mechanics that kind of ties all this together. It's called the normalization constraint. The easiest way to think about it is like a pie chart of all the possibilities. You might have a 30% chance of one thing happening and a 70% chance of another, but all the slices of that pie have to add up to 100%. They have to add up to one whole. No matter how many different outcomes a quantum system could have, the total probability is always, always exactly 1. 100%. This means that no matter how many particles are interacting or how many states are mixed up in a superposition, the system as a whole is always a single complete entity. There is a 100% chance that reality exists within that one unified set of possibilities. The total reality is always just 1. And that just leaves us with a final, pretty mind-bending thought to chew on. We know that everything in the universe is made of these quantum particles, right? So if the logic of 1 + 1 = 1 is true at that deepest, most fundamental level, does that mean our entire universe, with all its galaxies and stars and us, is actually just one single, unbelievably complex, unified quantum state?